Now that we did have a close look at objects, it's time to dive even deeper into objects, and not so much into that object literal notation with which we worked and into the different syntax features like destructuring, which we already had a look at, but instead we'll dive into a brand new feature, into a brand new syntax, which is related to a general programming concept that is called object-oriented programming. Now in this module, we'll of course have a look at what object-oriented programming is and why we would want to use it and how we can use it in a JavaScript application, of course. And to use it or to build an application with this OOP approach, but also in general, to have a nicer time when working with objects, we'll have a look at so-called classes and at instances. And of course, I'll explain what both things are and how we work with them. Now, related to that, we'll revisit the idea behind properties. We'll learn about fields, which are not that new, as you will see. And we'll, of course, also revisit methods, because classes, as you will learn, will help us with creating objects, and therefore we'll have to have a look at properties and methods again to understand how we work with these things in classes. Now we'll also dive into a concept called inheritance later in this module then, because that also, as you will see, can be very useful when you're building more complex applications with JavaScript. Now we'll have a look at all these things in a little demo application so that it's easier to grasp why we use these things or why we use these concepts and how we apply them to real problems. And with that, let's dive right in. So what is object-oriented programming, also often abbreviated as OOP? It's an approach, it's a way of writing and of structuring your code in the end. It's a way of thinking or reasoning about your code and planning your code. And the idea behind object-oriented programming is that you work with kind of real-life entities in your code. Now, I already mentioned this before when I talked about objects, so that's not that new. We use objects to group data together in the end, and we do so to, for example, create a movie object so that we can work with such a movie in our code, and we can think about our code in terms or in a way that's easier to think about to us humans. Now, object-oriented programming is just that. It's all about embracing that logic that we work with objects, that we work with objects only almost in our code, and we put all our code into different objects, so into different methods of objects in the end. Now, here's an example. Let's say we're building a very simple online shop. There we might have a list of products, and hence we might build such a product list component, which in the end holds all the data and, in methods, also all the logic that is related to outputting such a list of products. So it holds the logic for rendering a list of products, but also for fetching that list of products. And it probably also has a property or a couple of properties which help us store that loaded product data. So it's an object that holds the rendering and fetching logic and all the data that's related to it. Now we might have another object which reflects a single product. This object might be responsible for rendering the details about a single product, and maybe it also renders a button and it holds the logic to add a product to a cart. So that's the responsibility of this product, and therefore, of course, in this example, this product would be kind of linked to the product list. So inside of methods of the product list, we might be working with this product object. And then we might have a shopping cart object, which is also kind of linked to our product because we trigger the addition to the cart from inside the logic stored in this product object. And that shopping cart is responsible for, let's say, outputting all the products that are part of it and the total sum. And it maybe also offers a button to the user or renders a button to the user and holds the logic that is executed when the button is clicked to order the items. So that's a theoretical example. It is actually the example we'll have a look at in this module to learn about object-oriented programming and to also learn about another important feature, classes. But let's first of all start with this object-oriented programming approach. Let's start with this way of thinking about it, because for that we don't really need classes. So again, I'm in a brand new project, which you, as always, find attached, and it's the project structure you already know. It's a very simple index.html file, got a style import, got a script import, and got this div, which doesn't hold any content, will become important later. And then, well, we got some styles, which you can, of course, browse through. We got this empty app.js file. Now, I will build this very simple dummy shop here, not a real shop where we can really place orders, because for that we would also need a backend. We would need a server with a database and much more than we are able to build right now. But we will build a part of the front end here, a list of products where we can click a add to cart button, which will then increment the total amount in a shopping cart. And this will allow us to dive into the concepts which are important when you think about object-oriented programming, and then later in this module when we work with classes. So let's go to the app.js file, and as I mentioned, I want to render a list of products and I want to make sure that we can click on a button. Now, the traditional way of doing that, which we used thus far, would be to simply execute a sequence of steps here, to have a couple of functions in here, which we probably connect to some event listeners and which we also call ourselves from inside the code, and then write our logic with that. Now, let me make it very clear that this traditional approach doesn't have to be bad by any means. Indeed, you can also write big JavaScript applications only in a functional way, so only where you have all your code split up into different functions, which you then call in each other, basically. But this object-oriented approach might also be worth a look. So let's have a look here. So we need a list of products. And for that, we probably need a products array, first of all, with a couple of products in there. Now let's say in there we create products, which should be objects where every product has a title. Let's say a pillow has an image URL. And for that, of course, you can take any image you want. Here I picked one in advance, simply on Google image search, so find your favorite image URL there. Let's say we also want the price in the product, maybe $19.99, and a short description where I say a soft pillow. So this again is a string. This would be one product here. Now I'll add a second one, and here I picked a carpet, also again a URL I found on Google image search. And let's say it's a pretty expensive carpet or cheap one, depending on which carpets you regularly shop. And a carpet which you might like or not. So we got only two products here, but that should do the trick. So thus far, we're doing nothing object-oriented other than that we store our product data in objects. But that's what we did before already. It makes sense to group that data together instead of working with a couple of independent variables where it's not clear that they're related. Now comes the interesting part. Now let's add a product list object, and that's new. Previously, we wouldn't have done it that way. Previously, we would instead now have selected a part in our HTML code, probably a button, but we don't have a button here, so we'll have to render one. But anyways, we would have selected some part in our HTML code, and then we would have executed some logic to, for example, in this case, render a button. Now I want to move all my code into objects so that I only work with objects in my code. And the idea here is that the code then becomes easier to understand, because since all logic is attached to an object, it's easier to just look at an object and you know, okay, everything in there has to be related to rendering a product list, for example. If we then also have a cart object later, everything in there has to be related to, well, working with a cart. So here I have my product list object, and now actually we might want to move our products array into that if we think about it like that, because, well, rendering a list of products, the products themselves should probably be stored in that object then. So let's turn products here into a property of product list by replacing the equal sign with a colon and removing the semicolon at the end. And let's add a method, maybe a render method. And here I'm using that method shorthand notation. Now, the idea behind the render method is that it should, well, render that list of products. So now in here, I will need to select that part of my application, in this case, this div here, where I want to render everything, and well, then do render everything in there. So I'll go here to the render method, get my render hook, or however we want to name it. So basically a reference to the place where the app should be rendered to. And since this is a div with an ID of app, we can of course select the element by ID with get element by ID. The ID is app. And then in this render hook, we can, well, append some content. But for that, we need to create some content first. So here I'll create a prod list. And for that, I can create a new element, of course, with document create element. That should be an unordered list, probably, because I want to have a list of products. So it makes sense to have an unordered list to render all these products thereafter. Could, of course, also be an ordered list if you prefer to, but here I'm going with an unordered list. And to that prod list, I also want to add a class name. So I'll set the class name equal to product-list, simply because that is a CSS class which is prepared in here in the app CSS file to provide some nice styling. So now that's that. And now on that list, I want to render my different product items. So the different products I have here. So now we need to add the logic to render a single product here. So for that, we can go through all the products of this product. So this here, if we call render correctly, should refer to this product list object, and therefore this products refers to this array. So I'm going through all the elements in there. And then for every product there, we also need to create a new element which we can append to the DOM. So let's create a prod L here with document create element. Here a list item makes sense. Now on that prod L, I also want to set a class name, and there we can set it equal to product-item, another CSS class which I predefined in app CSS. And then to prod list, I want to append my prod L. Now this prod L, however, this product element should of course also output some content about the product. So we can set prod L and then maybe inner HTML to some HTML code in the end, which has the structure we want. So here I'm using backticks so that I can write a multi-line string here, simply because that makes it easier to structure the HTML code which should be rendered here. And there I want to have a div that surrounds everything, let's say. And then in there, an image with a source of, and now we can use this interpolation syntax to interpolate product.image URL. Every product here has an image URL property, and since we're looping through all products, we can access this here. Alt, so this alt text, before we close that, that can be product.title. Below the image source, we can now add another div, let's say. A div which should have a CSS class for some proper styling, a CSS class of product-item __ content. So these are two underscores here. And then in there, a h2 tag, which we also have to close, where we can output the title again. Then below that, maybe a h3 tag, which we should also close, where I output the price. And for that, I want to have a normal $sign. We have to escape that here to make clear that we want to use the $sign character in this template literal here, and not the meaning of the $sign, which would allow us to inject some content. And then here I can refer to the price. And thereafter, let's add a paragraph here where we output the description, let's say. So this, not this, prod.description. So that's wrong. This should not be this. This should be prod, of course, and here as well. And then below that, we can also add a button where we say add to cart. For now, this button won't do anything, of course. We'll have to select it and add an event listener, but let's worry about that later. So with that, we're setting some inner HTML. Then I'm adding product L to the product list. Product list, therefore, probably is finished. And now we can append this product list here to the render hook. So render it into this div. Now with all of that, we got all the logic stored in the product list object. And now we can go to product list here and call render. If we do that and we save that entire file and I reload, then indeed we get the products rendered here. Now the obvious question you probably have at that point is, what's the advantage of that? We put all the code into an object here, we don't really save much by that. Well, that's the problem with this object literal notation here. It's hard to write proper object-oriented code because with that object literal notation, which is great if we just need to create an object on the fly or just want to group some data together, but with that notation, it's hard to write reusable object code. For example, these objects here, they always have the same structure. Now, whenever we add a new object here, we have to add it manually with the object literal notation, and we have to make sure that we don't mistype or forget a property. It would be nicer if we had some way of getting some blueprint for this object, which we can just call, some function we can call, which gives us such an object or anything like that, which in the end just makes sure that we have to pass in a certain amount of arguments, and then we always get such an object generated. And of course, we could write a function which builds such an object, a simple function which returns such an object. That would be possible. And the same here. This logic for rendering a single product element, it's now part of the product list. It would be nice if we could have a standalone object which we could create multiple times, once for every product we have here in our products array, which holds all that logic, so that we don't have to put that logic in here, but have that logic stored somewhere else in our code, and then here we just execute it. Of course, that can all be achieved by splitting our code into functions. Don't get me wrong, that's not wrong. And that's also not a wrong approach. But it might be easier to reason about it if you split it into objects, where you have a product component object, let's say, which is responsible for rendering that part, a product list component, which is responsible for rendering the overall list, and later also a cart component, maybe a header component, which renders some header. And besides these components, which should be normal objects that just know how to render something, we also have non-component objects, which are just regular objects that hold some data. And that's something which we can build with classes. And once we work with classes, it will also be clearer what I mean. So let's have a look at what classes are. So I mentioned this concept of using classes. We haven't worked with classes at all in this course yet. Classes allow us to build objects in an easier way, or to build objects based on some blueprint, to be precise. So we have objects and we have classes. And the idea is that objects are the things we work with in code. And we work with objects a lot in this course already. Now, classes are something we can create in JavaScript too, which do not replace objects, but instead which allow us to define blueprints for objects, so that we can easily recreate objects based on these classes, because indeed objects then are also called instances of classes. So we can create an object based on some class thereafter. And therefore a class is just a definition of how the object looks like, which properties and methods it has, the place where we store our logic, and then the object is the concrete thing we build based on that class with which we work in our code. So this class-based creation, which I'll show you in this module, is an alternative to using object literals. It's not always better. Object literal notation is great if you just want to quickly group some data together, but it's awesome to use classes if you have reusable logic which you want to define in one place and then create multiple objects based on it. So classes can make the creation of multiple similar looking objects where the data differs but not the structure much easier. So let's translate this code which I wrote here into a class-based system. And let's start with this object in this array. This object always looks the same, and as I mentioned, we could create a function that builds us such an object. Well, a class in the end is such a function. It's just a different, more powerful way or an easier way of writing such a function. You add a class in JavaScript by adding the class keyword, just like this. It's a reserved keyword. And then any name of your class, the convention is to start that name with a capital character. So here, for example, product, like that. If you have a word that consists of multiple words, like product item, you would write it like this. Every subword starts with a new capital character. There must not be any white space or dashes in there. That would all be syntax errors. You could theoretically also name your class like that, starting with a lowercase character, but the convention is to start with the uppercase character. So now I got my product class here, and then you add curly braces to define what's inside of that class. And what's inside of that class is basically your blueprint of how an object created based on that class should look like. So you define which properties such an object should have and which methods it should have. Now, for that, you go into your class here, and there we can add a property, or here we would call it a field, and I'll come back to the difference in a second, it's not that big, by simply adding it in here. For example, title, and then you can assign a default value here, because keep in mind, the product class will always act as a blueprint. That's why I'm saying default, because typically you'll assign a new value. But we can create a default value of, let's say, default here. Now, one important note, which you can see right away, inside of this class definition, you assign values with the equal sign, not with a colon, which you would do in an object literal, but with the equal sign, and you end a line after such a field with a semicolon, not with a comma. That's one important difference. And classes do not replace objects, as you will see. Instead, as I mentioned multiple times, we build objects based on classes. So we might have a title, an image URL, which could be an empty string, or you just don't set any value at all. Then it will be undefined initially. And also a description, and also a price. Now this would define that objects based on product will have these four properties thereafter. Now I mentioned I call them fields here. Once we create an object based on such a class, every field will be translated to a property in that object. That's how that's related. We just call it field here because the class is not the concrete thing with which we work here. Instead, it's just a blueprint. It's just a definition of an object. And what becomes a property in an object is just called a field here. However, for the rest of this course, I'll also use these terms interchangeably because in the end, they're closely related. So now that's how a product would look like. Now the question is, how do you now create an object based on such a class? Well, you go to the place where you need it. That could be here in your global script or here in this array of products. And then you refer to the class name, product. You execute it like a function, and very important, you add a keyword in front of it, new. And we've seen this new keyword before in this course. I sometimes showed it. New in the end is a keyword JavaScript understands that together with such a function execution, which is based on a class, it's not a real function, but still, should basically create a new object. That's what new together with this function execution does. Neither of the two alone works, we have to combine them. So now this gives us a new product object. This returns a new object which has this structure. And therefore, indeed, if we comment this out for a second and we just go here and we console log new product to have a look at how this looks like, such an object. Let's save that. Since I added this globally, it should execute right away when the script runs, and then reload this page. Also, make sure you're using Chrome because classes are not supported in old versions of Internet Explorer, for example. And I'll come back how to still make them work there in the browser support module. So reload your page thereafter, and what you should see is this object which is getting logged here, which has a title property with a value of default. Please note that this is a regular object with a regular property, hence we have a colon separated key value pair. And then we have the three other properties which are part of the object, but which have no value because we haven't assigned one here. So that's the first step towards classes. We now know how to define one, but it's not that useful yet. When we create a product based on such a class, it would be nice if we could create it with some initial values. We could, of course, assign all values in here, but then all products which we create based on that product would have the same values. Instead, I want to make sure that when we call new product, we can kind of pass our initial values here to new product so that we can create a new object with some initial values. Of course, by the way, we could, of course, create a new product like this and then just assign values with the dot notation. But that's not what we want to do. We want to create it in one go. So let's have a look at how that works in a second. So when I call new product, I want to create a product with different values than the default values here. It would be nice if we could call new product and just pass information to that product function. Because we called it like a function, wouldn't it be nice if we could pass some arguments like a title, a price, and so on here? Well, it turns out you can do that. And for that, you go back to your class and you add a method to that class. Now, a method is added just by adding some name, and this can be any name of your choice, of course, then parentheses, and then curly braces. So like this method shorthand you learned about, important, you don't add a semicolon thereafter, and you also don't have an equal sign in here. It's just this shortened here, right after any fields you might have added. And you can, of course, have more than one method. You can add another method like this, just in a new line, no semicolon thereafter, just like that. Basically like you would create a function outside of a class, just without the function keyword. So here, however, we don't add the SumName method. We'll add custom methods later, but now we need a special method. A method which JavaScript automatically calls when we create a new instance of this class. And we create a new instance when we call new and then execute this class like a function. And this special method which JavaScript executes for us is called the constructor method or the constructor function. We add constructor here as a method name, and that's a reserved name, and then parentheses and then curly braces. The idea behind a constructor is that it can accept arguments like any normal method, and there, for example, we could accept a title, image or image URL, or however you want to name it. I'll just name it image, a description, and a price. So you can accept any arguments, any parameters you want, just like that. And in the curly braces, and that's the interesting thing now, you can assign the values you're getting here for these parameters. So you can assign the arguments you're getting to your class field, so to the properties of the object when it is instantiated then. And you do this with the good old this keyword. This in here refers to your class, or to be precise, since this class will be used to create an object, to the object that is created. So we can then, for example, say this title and set it equal to the title argument. So this title here refers to the property title, which is added to product, so to the same property this field would add. Title here refers to the title argument. Therefore, we can also say this image URL and set it equal to image, so to the value we get in this parameter. Same for the description. We can set this description equal to desk and this price equal to price. Now that will create a bunch of properties on the object which is created with this call here, and initialize the values of these properties with the values you passed to the constructor. So now we can pass in a value for a title, like a pillow. Thereafter, second parameter is the image. So let's grab that image URL and pass that in here as a next argument to our constructor call. And you call this like a normal function with the different values for the different parameters separated by commas. Third parameter is description. So let's grab this description here and add this after the image. And last but not least, I have the price which I add here. Now let me restructure this with my shortcut. And now we can get rid of this object, because now we create our object with new product. And the same for the carpet, of course. Here we can say a carpet, grab that image here, and replace this image here with that image. Adjust the price to 89 to .99, and also replace the description. And thereafter, we can get rid of this object as well. So now we're using this class as a blueprint, and the huge advantage here is that we now have an easy, reusable way of creating objects which are guaranteed to always look the same. It's impossible for us to omit properties or to mistype properties because it's all defined in here in this class definition. So now if we save that and we reload, we get the same output as before because we're working with normal JavaScript objects in the end. Such a class, when we instantiate it with the new keyword, returns a normal JavaScript object, but in a more convenient way, as I would argue. So we learned these basics about classes. Let me come back to that class field versus property thing, because it is important to get that right. If you have a class that looks like this, then this here would be called a class field. This here, when you will use it in the constructor, would be called a class property right away. So title is a class property, category is a class field. But it's important to know that in the end, this is just a theoretical separation. A field becomes a property when we create an object based on the class. We just call it property in the constructor function right away because the constructor gets called during that object creation process. So there we get a property right away. You don't really have to memorize this difference, though. In the end, fields are like properties. We define them in a class so that we have a property when we create that object based on the class. The thing here at the bottom, print info, by the way, would still be called a class method or an object method. In our code here, the implication is that all these things here in the constructor function are properties. Of course, I got fields of the same name, which is no problem because these would be created as properties when we instantiate the product. Now, we basically override everything we set up there in the constructor, and therefore you can actually remove that. This definition here is not required to be able to assign values. In the constructor, you can add properties for the first time, so without having defined fields for them before, just like that with the this keyword. And indeed, it makes no sense, or it rarely makes sense, to define fields here if you're assigning a value to them in the constructor right away anyways, because then you just basically override that default logic where every field would be translated to a property because you manually assign a value to that property and therefore add that property anyways in the constructor. So this can be removed here. It's just something which will become important later again, where we also work with fields which we don't initialize in the constructor. For now, that's not the case. So our object can just look like this. Our class can just look like this for the moment. So we got our first class added. Now, our code, however, still is such that all the logic lives in the product list. Time to change that too. Let's add another class, because we cannot just create classes which predefine objects which are basically data containers. We can also create classes for objects which hold more logic, so that in the end our entire application logic is split up across multiple classes, which we then just connect in some clever way. So therefore we could create a class here, which we just name product list, again starting with a capital P here. Now such a product list class could have our products array, and now here that could be a case where we set this as a field and set this to a value right away. The value, of course, can be our array, which I otherwise would have created down there. So let me cut the logic from there. We'll remove that code at the bottom anyways later. And initialize products to be an array. Now again, what will happen here is that when we create an object based on this class, a products property will be added automatically and the default value will be that array. Now we could add a constructor here, but we won't need to set this products to anything because we initialize it anyways. So we don't need to do that here. Let's leave it empty for now. We'll see if we need it. Instead, what I want to add here is a method, and that's my render method, which we also have down there, right? So we can take that logic which we have in the render method, and in the end, cut it from there, remove this entire product list object therefore, and just put everything here into the render method in the class. With that, we haven't gained much, but we're getting there. Now we have to fix the code down there. Product list here no longer exists. Instead, now we have to instantiate our class, maybe create a product list object now with new product list, and then there we could call product list.render like that. That's how we could do it. And if we save it, with that, we should see the same result as before if we reload. But we're not there yet. It's not the final result I want. Instead, now I want to outsource the logic for a single product. So what we render for a single product into another class. So I'll add another class, and the order of classes, by the way, does not matter. When your script loads, JavaScript will parse it entirely before it executes it, and all the classes are then understood and recognized by the JavaScript engine. So if I refer to a class inside of product list, I don't have to define it in front of product list. I could define it thereafter. JavaScript will be aware of all classes. Same here for product. I'm using product in product list. The same code would also work if I cut product, if I cut the product class from there and move it here to the bottom after the product list class. Only important thing, all your classes have to be defined before you execute any code where you might use them. So if I would move the product class after these two lines, we would get an error. Moving it here will work though. So if I now save that and I reload, you'll see the same output as before. Still, here I like to have my product class first, also because it's a pretty simple class which just defines the structure of well, very simple object, but the class order does not matter as long as you define all classes before you execute any code where you need them. But back to our new class, and that would be the product item class, let's say. Of course, these class names are always up to you. And that should be a class that is responsible for rendering a single, well, product item, unsurprisingly. For that, we can add a constructor, and we could accept a couple of properties that make up a product. To be precise, title, image URL, and so on. Basically what we already have in there, and therefore we can also just accept the overall product object which we get. So then here we could say this product is equal to product, and I just expect to get a product which has this structure here in product item. I do split this into a product and a product item object here because this product up there should just define how a simple product looks like, just which data is in there. It just is there to group data together. Product item down here should not group data together, or not primarily. Instead, this class will now also hold the logic to render a single product item. So here we could add another render method. And of course, you can name this method however you want. Doesn't have to be named render. And then there, I want to have the logic for creating that single product element. So we can actually cut all that code here, cut it from the product list, and move it into this render method of product item, so that I create my product element there with document create element. And now here, of course, when I access image URL and so on, I have to reach out to my product property. So in here, since render belongs to this class here, it should normally be called on an object created with that class. So therefore here we should have this available, and this should refer to the object created based on the class. Now on this, we should have a product property. So we should be able to do this dot product and then dot image URL, because every product object has an image URL property. So same for the title, should be this dot product dot title, also of course down there, this dot product dot title, this dot product dot price, and this dot product dot description. That should all be available here. Now with that, I have the logic to render a single product in my product item. The problem we have here is that this creates a product element but doesn't know where to append it. Now we got two possible solutions for that. Solution A is that the render method accepts a element, a DOM object, where we can call append and append this to, or that in this render method we instead return the created product, and wherever we call render, we have the responsibility to then use that returned object and append it. And that's the approach I'll go for. I will return prod L in here in render. And now we can just go to the product list. And in here, where I go through all products, we can now create a product with new product item. Let's also maybe name it product item here. So by using the product item class we just worked on and constructing an object based on it, to that, as you learned, you have to pass a product. That's what we expect in the constructor, and that's what we pass between parentheses when we create a new object with the new keyword. And prod here, where I go through all products in a product list, conveniently is just such a product object. So here we can just pass in prod. And then we can create our prod L or get access to the created prod L here by calling product item.render. And as you learned, render will return this new object. So now we can append product element again because prod L is such a DOM object created by render, but by render in product item. And now we might be able to see the advantages of this object-oriented approach become clearer. Now we already split our logic in some classes, and yes, of course, it's still in the same file, but if you're now coming to this code, if you're a new developer working on the project, and you want to find out where's the logic for rendering a single product, then you don't have to scan through all the file, you just have to find this product item class, and it will be pretty clear that, yeah, here, this is what's responsible for rendering a single product element. And you don't have to worry about the other code. So it can make your code more readable and more structured. And that's the idea behind object-oriented programming. Well, with that, let's save all of that and let's reload this page. And again, we get the same result as before, but now with two classes that are involved in rendering content. And now this also shows you how you can have classes with logic attached to them, besides having classes that are just blueprints for data containers, which also, of course, are very useful. But here, this helps us split our logic, which makes our code more readable. Now let's continue working on this mini application, and let's make sure that clicking on this button here actually does something. Now there are various approaches to making sure we can reach out to that button. Approach A would be to not add it here in inner HTML, but instead add it as a object you create with document create element. Then you would just have to get access to some part of that rendered HTML code, to that div, for example, so that you can append that created object. Therefore, approach B is the one I'll use, is where I have the button in there, but then I need to get access to it. And for that, I can access to my add cart button, or however you want to name that constant, with the help of prod L, which is that element we created. And then in there, we can of course use query selector, for example, to select the first button we find. We only have one button in there, and therefore this is the button we get access to. Now please note, since I execute this inside of the render method of this class, this always applies to this snippet, which is created for this concrete instance, which is later created on that class. So the fact that we'll create multiple products and therefore have multiple buttons on the screen does not cause a problem here. Because when this code runs here, this entire code, we're only looking at a single product because we're in a single class which is responsible for creating a single product. So we will run this code on this snippet which only holds one button, and therefore we get access to exactly that button for this product. Now here I then got access to this button. Now we can add an event listener here, click listener, and execute a function, or to be precise, probably a method. Because adding a product to a cart, well, for me that again makes sense to be a method of this product item class here. So we can add another method. Position doesn't matter, doesn't have to be above or below render. You can add it anywhere because JavaScript parses and kind of saves that entire definition before your code executes. So here I will add it above, but that's not a must do. And I will call this method add to cart. Of course, it's totally up to you how you call it. And in there, I then want to later add logic to edit. For now, I'll just connect this. So here on add event listener, I'll point at this add to cart. And then here, I will console log adding product to cart. And I'll also console log this product so that we can see which product was added. So now we're adding this event listener down there. Let's now have a look. Let's save that and reload and click add to cart. And what you'll see is something strange. You see undefined here. So you don't see the product which we clicked on, which should be the pillow, but instead undefined. Now why is that? Well, it's related to the behavior of this, which I talked about in the objects module. We execute add to cart whenever the button is clicked. We assign the add to cart method of this object, of this class, to this button. or to this event listener. Now, as you learned in that object module, JavaScript then binds this to the source of that event, so to that button, and not to your class or the object where this effectively runs on later. The solution, or one possible solution, is to use bind here and bind this. So that means that we bind this inside of add to cart, so what this refers to inside of this method, to the same thing this refers to in this place here. And this here in this code snippet refers to the entire object, so to this product item object, assuming that we call render on an instance of this object, which is exactly what we're doing down there. Here we create the instance, here we call render on that instance. So therefore this now should refer to the correct thing, and hence if we save that, we reload and click here, indeed here I log this product object. So that works now. Of course, that's not the final logic I want to execute if we add something to a cart though. Instead, I want to have an object, a cart object, probably a cart class, which also renders some output to the screen, which in the end then holds a list of all the products and calculates a sum, which then is output on the screen. So time for another class. Let's add a cart or a shopping cart class here. Up to you how you want to name it. And in there, I want to have a items field, which initially is empty. And I also want to have a render method here, which renders something to the screen. And that something should simply be, let's say, the total amount and a button that allows us to order the items. You could, of course, also go more fancy than that and also render all items. But to keep this module short or relatively short, I'll just render the total. So in here, I'll create my cart element with document create element. And here I'll go for, let's say, a section element, section tag. And then set cart L inner HTML equal to some HTML code. Again, written across multiple lines to make it easier to read. Where I want to have a h2 tag, which will output the total amount. Then I want to output a $sign here, so we have to escape it with a backslash, and then we can interpolate the total amount. For now, I'll just output 0 here. This will soon refer to something dynamic. And then also a button where we could say order now, like that. Now also assign a class here to get some proper styling with class name and set it equal to cart. That's another style you find in app CSS. Whoops, and that should be a semicolon. And of course later I'll also add an event listener here, but for the moment I'll just return cart L here in the render method so that wherever we create that shopping cart, we can append it to the DOM. Now, where is that place where I want to use the shopping cart though? Well, that should probably be a new class which kind of combines product list and cart, because the cart item, the cart HTML content is certainly not part of the product list, so rendering it here would be incorrect, but that is the thing which we rendered to the screen initially. So we probably add a new class which you could name app or shop or page or whatever you want to name it. I'll name it shop. And in there, I'll now also add a render method. And here I want to combine cart and product list. So now in the end, I'll grab this code here, create my product list in the render method, and also create my cart here with new shopping cart, and then call cart.render here. Now, product list right now always renders itself into that app place here of index.html, into that div here. We now need to change that and kind of cut the render hook from the render method of product list and move that into shop, which is now the new place where we render everything to the screen. And now we need to make sure that instead the render method in product list returns that prod list. So also cut this code and instead return prod list here, just as we do it in the other classes. And then here in the shop component, we just need to store these returned elements. So here we got the cart element, and here we got the prod list element. And then here in render hook, we append the cart, and thereafter we append the prod list element. And here, of course, the cart element. Now we just have to create our shop here with new shop below all these class definitions, and then call shop render. And this will then render the individual parts, and the result should be that if we save that and reload, indeed we now have that cart area here at the top. Now for the moment, of course, nothing changes when I click add to cart though, or we only see that output, but that does not change the number here. And it can't because we haven't added any logic to do so. So that's the next step we should do. And that will also force us to make sure that we can communicate between our different classes, something we haven't really done before. Thus far, every class works kind of standalone. Yes, we return the created element and use that in our classes, but for example, that event listener on the add cart button, it triggers this method and there nothing happens. Well, now we have to make sure that when this method is executed, we actually do something which leads to our cart class to update. Our cart class will need to re-render. Now, as it turns out, that's rather difficult right now. In our shopping cart class, we could certainly add an add item method or something like that, where we expect to get a new product in the end. We could, of course, therefore also name this add product, probably a better name. And then we could refer to this item, so to this field, which we initialize to be an empty array, so to this property, which initially is an empty array, and push our product onto that array. That's something we could do for sure. Thereafter, we could call render again to re-render this, but that, for example, wouldn't work because it returns a new cart element, not something we want here. We want to update the existing content instead. Well, that's something that could be done though. We could go to render, where we render our content, and simply make sure that we store this place where we output that number so that we get access to this h2 element. Here, we could say this total output, or however you want to name it, and therefore add a new property. And you can add new properties anywhere in your class, in your object. Doesn't have to be inside of the constructor. As you learned earlier in the course, you can always dynamically add new properties to an object. So here we add a new total output property to the object which is created based on this class, and set the value equal to cart L, referring to that element we're creating here, and then query selector h2. So we get access to that h2 element and store a reference to this element here in the total output property. Now here in add product, we could then set this total output equal to, and now basically copy that code here, therefore use this template literal notation here with the backticks, and now set this to the old total plus the new total based on the items we have here. For the moment, I'll just set it to 1 and we'll add a real dynamic solution later. For now, I just set it to 1 so that we see that it changed at least. So now we would have an add product method that probably should update what we see on the screen. The problem is, how can we call that add product method from inside of product item? Well, you could think, I just call cart add product. Well, that won't work. Cart here is not a variable you have available here. Cart like this, or to be precise, shopping cart, so referring to the class itself like this won't work. You have to instantiate it to work with it. You can't work with a class just like this, at least not in that way here. Now we do create the cart here in the shop. Here we have a cart instance where we could call add product, but here unfortunately we're not adding that product. Now how can we solve that? Well, turns out there is a way we can actually make a syntax like this here work, and that will help us solve that. Let's have a look at that in the next lecture. When you work with classes in JavaScript, you have these properties and methods and fields, which you already learned about, which are all instance properties thus far. Well, turns out you also have something called static properties and methods. Now let's have a look at what the difference between static properties and fields and methods and instance field property and methods is. Now, static properties and methods are defined with the static keyword in front of them. The difference to the instance properties is that the static properties and methods are only accessible on the class itself. So you don't need to instantiate the class. You don't need to use the new keyword to create an object based on that class. And we typically use this on helper classes or for some global configuration, etc. And instance properties and so on are instead defined without the static keyword. That's what we did thus far in this module. And they're only accessible on the instances based on that class. So we use that for all the core reusable logic. For example, in our code thus far, we only work with instances. We always reuse all these classes by using new because we need different product items which have the same structure but hold different data. With static properties and static methods, we have a class which is not instantiated and which therefore always works on the same data, for example. But that's exactly what we can utilize here. Here we could add a new class, maybe name it app because it holds our overall app, which is created like a regular class, nothing special there. But in here, I add a new method, init, where I now add the static keyword in front of it, and that's new. Now we can move that code here, for example, into init. You can execute any code in there. Just be aware that if you would use this in here, you would always refer to the class itself, not to an object instance based on that class. And now you therefore also don't create a new app like that, or at least you could do that, but to call init you don't do it. Instead you can just call app referring to the class itself like this, .init, like this. And this will execute this init method directly on the class itself. Now again, we therefore have no app object we work with. Instead, we directly operate on that class, and hence this will work, but it's a different approach. Now, the advantage can be seen if we now solve our cart problem. Remember that on this cart here, we got this add product method in the end. This accepts a product and then should update the rendered cart. Well, what we can do now is, for example, on the shop, which we initialize an app, we can store this reference to the cart object in a property. So this cart is equal to shopping cart. So now this is a property of shop with this cart. Of course, that means that here where I refer to cart, I also have to use this cart. And the advantage of this is that we can now go to our app class here, and in init, we get access to that shop, right? And that shop is in the end an object based on the shop class, which holds this cart property, right? So here we can also add a cart property by referring to that cart property on shop, like that. If we save that and we reload, this should still work. Now, why am I doing that though? Because now here in app, I can also add another static method, add item or add product to cart, expect my product here, and now refer to this cart and call add product on that, because this cart, don't forget, refers to an instance based on our shopping cart class, and there we have that add product method. And then call add product there and forward that product. So we kind of use this app class and this static method as a proxy. Because, and that's the advantage and the whole idea of using these static methods, since we always operate on the class and not on instances, we don't work on different objects, which we would do if we would not use static and instead create different apps in different places of the app. But instead, the app I'm using here to init my app, this class, is the same I can now call from inside product item. So here in add to cart, we can get rid of that and instead just call app add product to cart this product, referring to the product stored in this product item. So here I'm utilizing static methods and the fact that we're not working on objects based on classes, but on the class itself to share some data, share the cart instance, for example. Now, of course, that's not the only way of solving this. You would be able to find other approaches too, but it's a nice case for static methods in this case. Now, important, here I'm calling add product to cart on app, and I'm forwarding this product, referring to my product and product item. Now, here, however, we'll have a problem. If I save the code like this and reload and click add to cart, we'll get an error. Cannot read property add product of undefined. So it can't find the add product method on cart, because here I'm trying to store cart, which I get from shop cart, before calling render. If you watch closely, you see that it's in render where I create the cart. So this won't work in this order. Instead, we have to swap that and first render, and then we got access to the cart. So now if we save that and we reload, it'll still not work because I made a mistake earlier, as I recognized. Here in shopping cart, where I assign a new value, that of course shouldn't be total output equal. It should be inner HTML equal, because I want to update the HTML content in there, not the value stored in total output. And with that, if we reload, now you see that changed to 1. Still not the real value because we haven't added the logic for that yet, but at least we see a change. So that works. And now we connected two classes with the help of static methods. Now, one side note, it's optional, but still I would say it's a good practice. You can also add a static field here to the app class, which is named cart, so that we make it clear that we have this static cart property. We refer to it here with this cart, and if you use this in a static method, it always refers to the class itself, doesn't try to refer to an object based on the class. So it adds a static property implicitly and accesses this static property implicitly therefore, but still this makes it clearer that we expect to have that static property. Not needed technically, but I think it improves readability, and as a side effect, it also allows me to show you how a static method or property would look like. Of course, you can also initialize this to some value if you need one. Here we don't need that, and therefore the code is good like this. So now we had a first look at classes. We're using some classes to split our logic, and we're also using classes in different ways. We have our class with the static properties and the static methods to glue together some of the other classes, and that's just one possible use case. Static methods and static properties are always a good idea if you want to share some functionality across different parts of your application, or like in this case, if you want to share some data or use this as kind of a communication interface, you could say. Now, of course, that's not all you can do with classes, or that's not all that's to classes. Before we dive into more things we can do with classes though, and before we can work on this app a little bit more, because right now, for example, this cart total, of course, is not behaving correctly, let me take a step back and go back to the relation between classes and the objects you work with in JavaScript. For one, of course, it's important to realize that if you're not using a class in a static way like this here, but instead by instantiating with new, what new shop in this case here returns, so what's stored in the shop constant here, is a regular JavaScript object, or a reference to that object, to be precise. So it's in the end the same as what you get with that object literal notation. I really want to emphasize this. As a result, you can of course use all the things on these objects as you can do on normal objects, because these are just normal objects. You can, for example, use destructuring to get the card out of shop if you wanted to do that. Something like that is possible. It's really important to understand this relation. It's also important to understand when to use classes. You might think that with classes, the old way of creating objects with the object literal notation is obsolete. And that would be wrong. It's not obsolete. It's great to use that object literal notation if you have some data collection, a couple of variables, which you in the end want to group together, and where you only want to do this once or in one place of your app, of your code, and you don't plan on reusing that. So not as we're doing it with the product, where we need that in different places, where we want to ensure that they always have the same structure, but where you quickly want to create such an object on the fly. That's a perfect use case for using object literals. They're quick and easy to use, you have no extra overhead, and you also have a small performance benefit versus this class-based instantiation, which is quickly made up for though if you would unnecessarily create multiple objects with object literals instead of using classes and therefore sharing code, just to also say that. So classes in general are a good idea if you have some logic which you want to reuse. If you want to recreate the same type of object with the same structure and the same attached logic over and over again, like in that demo application we worked on. You have a little bit more overhead initially because you need to write that class definition, but thereafter you have that easy object duplication, of course not really a duplication, instead new objects are created with that same internal structure but with different data, depending on how your class works, of course. So both is important and both has its place in JavaScript, and it's simply also something that comes with experience and with you working with JavaScript, that you get a better feeling for when to use which. In this example application here, classes make a lot of sense because that allows us to cleanly split our code, and we are actually reusing quite a lot of these classes or the logic attached to these classes in different places of our code. So here, having classes makes a lot of sense. Now, before we move on to more exciting features about classes and how we can improve that code here, let's first of all dive into another nice thing you can add to classes where you already learned about when we talked about objects. And that would be getters and setters. You can add them to classes as well, and the shopping cart here is a perfect scenario. There, I am editing my items, and I then want to update my output here in the end, right? Now, we could use getters and setters as an elegant solution for that. We could add a getter, maybe name it total amount, like this, and we do this with the get keyword, as you learned in the objects module, then any name of your choice, and then like a method, like this method shorthand, and in there you have to return a value in the end. Now, the value I want to return here is the card total. And for that, we can use a technique we learned about in the arrays module, where we simply reduce our list of card items to a single number. Now, since we in the end just store products and items here, every product has a price property, so we want to reduce that. So here we can calculate a sum with this items reduce. Items is an array, so we can call reduce on it. And as you learned, reduce takes two arguments. A function, and here I use an anonymous arrow function, and then an optional second argument, which is our initial value, and there I'll start with 0. Now that function, which we pass in as a first argument, itself also receives multiple arguments, and there are two important arguments which I want to accept here. That's the previous value and the current item. You can name the parameters here however you want. Inside of the function, I then want to return previous value. For the first run, this will be 0. Thereafter, it will be the value returned by reduce, plus cur item, which will refer to an element in the items array, and therefore that's a product, dot price, because we'll have a price property on every item in items. If the array is empty initially, then this will automatically return the initial value, which is 0. So that's my reduction logic. We can even shorten this now, as you learned. Remove the curly brace and the return statement, remove the closing curly brace, and also remove the semicolon here. And then reformat that, remove that extra comma, and now we have the reduce function with the arrow function here and the initial value. Now it's the sum which I want to return here, and here in my template literal, I therefore want to refer to this total amount when we add a product. But actually, I even want to change that logic, and that's now totally optional. I'm doing it so that I can also show you setters. I'll add a setter, and I'll name it card items. It will get a value, and we create it with the set keyword. And in here, I want to set this items equal to value, because I expect value to be an array of card items. So I override the existing array with a new one. Now I also then want to run this logic here, so I'll move it out of add product and move it into the setter, so that whenever we set new card items, I actually recalculate the total amount and update the HTML code, so that this happens as part of the setter here. Now in add product, I'll then just create a new constant updated items, which is a copy of this items using that copy trick with the spread operator in a new array, so that I have a real copy of that items array. And I then add that new product to that copied array, and then set this card items, referring to the setter, equal to updated items. And this will trigger the setter, pass updated items as a value to it, and then therefore update the code like this. Now, we could have kept the old logic, but this allows me to also show you setters and getters in classes, which you can add just like that, basically as you would have added them to normal objects. You can add them to the blueprints, which will be used to create objects like this. And then this logic will be added to the actual objects that are created when you instantiate this class with the new keyword. Now with that, if we reload here, you see this works. If I can now click add to cart, this indeed updates with every click on the item. Also, if I click on the carpet, then you see this makes much bigger jumps because the carpet is more expensive. Now a tiny adjustment I want to make at this point, I also want to call toFixed2 here. This is something we haven't really used before. This will prevent this strange output if, because of this floating point imprecision, to which I'll come back in a separate module, we would get an output with a lot of decimal places. This basically tells JavaScript to always output a string, convert this number to a string which only displays 2 decimal places. That's what toFixed on total amount, which is a number, does. That's just something I do add here to make sure that we always output this in the right way, so to say. So that's now the logic added to the shopping cart, and with that the classes don't look that bad. There is more we can do with them though. In this application we got a couple of classes: product item, product list, and also shopping cart. And what they all have in common is that they have a render method, and in that render method we do different things, but we always create a new element. We then add stuff to that element, for example with inner HTML. We then return that element. Now we duplicate that logic. Of course the exact configuration, for example the class name and the tag, that differs, but the general logic always is the same. So whilst we do have different logic for what we then add to this element, the creation and configuration, basically, as I just said multiple times, is the same. And in such cases, we can use a concept called inheritance, which we can use in many programming languages, and JavaScript is no exception, to conveniently share code amongst classes. Now let's explore that concept. The idea behind inheritance is that we have some base class, let's say a post if we're building a social network, which holds a couple of properties and or methods, in this example 3 properties, which we also need in other classes. Let's say we have a specialized version of that post, which is an image post, which also has all these properties, but also in addition has an image URL and an image description. And then we also have another specialized version of a post you can make, a video post, which also has title, text, and creator ID, but which then also needs a video URL and let's say a rating regarding the age you gotta have to watch the video. So we can of course build multiple classes, but that's suboptimal because we duplicate a lot of code. All that purple code, title, text, creator ID, these properties, we duplicate them all the time. So instead, it would be nice if you could extend that base class, and of course you can do that in JavaScript, and therefore inherit all that purple stuff. So you can extend that class and then you get this shared purple content automatically in the specialized classes, and you can still add your own extra properties or logic in these subclasses here. You can also override things shared in the base class if you would want to do that. And now that's something we can utilize here. This concept of inheritance is something we can utilize here in our project as well. Back in our project, there we could add a new class, and I'll add it here above my other specialized classes, so to say, which you can give any name you want, and I'll name it component, because in the end this will be a class I use to output different, you could say, components, parts of my web page. Now, such a component class will have a method which I'll name createRootElement, which receives 3 arguments. The tag of the element I want to create, so I'll use that later to basically replace this line here. So I want to have the tag. I want to have any CSS classes that should be added, and any other attributes that might need to be added to that element which is created here. Inside of createRootElement, we can then create that root element here. You can of course give that constant any name you want with document create element and pass in that tag. Then check if we have that CSS class constant set. So if that is a truthy value, if CSS classes is a truthy value. If it is, then I'll go to the root element and set the class name equal to CSS classes. So I expect CSS classes to be a string of CSS classes that should be added. Else I'll do nothing, so no need for an else block. After this if check, I'll add another if check and see if attributes holds a truthy value. So if that's basically something we can work with. And also if it's not just truthy, but also if it's an array with a length greater 0, because this should be an array. And if both is true, I'll go through my attributes here with a for off loop. You could of course also use a for each loop if you preferred that. And then on the root element, I will set an attribute with the setAttribute method, where I expect to have a couple of objects in this attributes array, where every object has a name property and also a value property. To guarantee the structure, we can add a new class, element attribute, for example, which has a constructor where I get the attribute name and the attribute value. And then here I say this.name equal attribute name, this.value equal attribute value. So we store the data we got on the constructor in properties of the class. And then here I essentially expect attributes to be an array full of objects created based on that class, so that we can set attributes on the root element. Well, and then thereafter, I also want to append that element to the DOM. For that, I need a place where we can add it. And for this, I'll actually add a constructor to component, where I expect to get a render hook value as a parameter, and then store this in some property of component. So a property for that component class. And this hook property holds the data passed into the constructor. And of course, I'm just coming up with one possible way of implementing this. You can definitely build this in a different way as well. This is just one example. Let me really emphasize that. So here, once we created the root element, that HTML element with that given tag, I want to add it to this hook, so to this element I got on the constructor. And to be precise here, I expect that hook should not be the element itself, but let's say the ID of that element. So maybe rename it to hook ID, so that down here we can say document get element by ID for this hook ID. So for that ID we got here in our constructor. and then call append and append that root element here. That's the idea here. Thereafter, we can return this root element here. So now we have this component. How can we now use this? To inherit from this component class, which I want to do on shopping cart, product item, and product list, since these are all methods that render something, to inherit from that class, I go to, for example, the shopping cart, and there we now add a new keyword after the name of the class before we add the curly braces that mark the class body, and we write extends here. That's the keyword, extends, and then we write the class from which we want to extend. And you can only extend from one class. So inheriting from multiple classes is not available in JavaScript. Some programming languages have that. Most modern languages don't really have that. JavaScript certainly doesn't have it. You can only inherit from one class. Now, what does this mean now? It means that shopping cart now still creates normal objects if we instantiate it, but all these objects don't just have all the logic we defined in here, but also all the logic we defined in the base class. So also the create root element method, for example. This is available in every object we create based on shopping cart. The implication of that is that we can go to the render method now, and instead of creating our cart element like this, we can now refer to this create root element. And my IDE even supports this here because this here, when we call render in this class on an object created based on that class, this will refer to this object. And as I said, this object will hold everything or will have access to everything that's part of the parent class as well. So create root element is accessible via this in the subclass. So I can call create root element here. Now as a tag, I'll pass in section. As a class name, I'll pass in cart, and therefore here we can get rid of this line. And create root element, of course, returns an HTML element, the element that was added to the DOM. So I'll still store this in CartL because I need it here in render to define what exactly I want to do here. I can't move that code here into the base class because this differs for every class. This here is specific to the cart. We don't need that on the shopping list. So it's only that part where we create and append the element to the DOM that can be outsourced and that is now part of a separate class. The specific rendering for this cart item, that's still part of this cart class. That's how this works. So now with that, if we save that and we reload this page, we get an error. Now, do you know why? Well, we get an error because we can't append on nulls. We basically have a problem when it comes to appending the created element. And that makes a lot of sense because let's revisit create root element. There I need that hook ID to append my root element. Now hook ID is set in the constructor of this component we inherit from. And the question now, of course, is where do we call that constructor? When we call new cart, here in the end, new shopping cart, we call the constructor of shopping cart. So when does the constructor of this component we inherit from get called? Well, when it comes to constructors, there are a couple of rules. If your subclass, so the class which extends another class, does not have a constructor, the constructor of the parent class is automatically called. The problem here just is, yeah, this is getting called, as I can prove if I just output something there. Let's quickly add that and then reload. So this is getting called, but of course, render hook ID is not passed in because how would JavaScript know what to pass in there? So it's getting called, but without any values. Now, if you add a constructor, maybe below the getters and setters, to your subclass, so to the class which is extending, then this constructor will be called, and the parent class constructor will not be called. So also not what I want. What I in the end want here is I want to call this constructor and from there call the parent constructor. So the constructor of the parent class, which is the class we're extending from. And we can do this with another special keyword, the super keyword. execute it like a function, and this will call the constructor in the parent class. And you want to do this in your own constructors if your parent class also has a constructor that should be executed, which typically is the case if it has a constructor. Now, one important note about super: when you add super to your constructor, make sure you're not relying on any field in that super constructor method. That will become important later. And also, if you plan on adding properties in your constructor with this something equals something else, you have to do that after you called super. You always have to call super, so the constructor of your parent class, of your base class, first before you start using this inside of your subclass constructor. So now we can call super here and forward a value for that render hook ID. So an ID which we find in the DOM. Now for that here, let me go down to shop, where I also have a render method. And the ID where I want to add card to for now is just app, right? Because that's what I'm doing in shop here essentially. I get access to that render hook in my document, and then I append the card element and so on. So in the end here, in shop, I no longer need card element, so I can get rid of that line as well. And instead here to shopping cart, I want to forward app as a string, so that value of that ID here, which I want to use as a hook to render that item. And then in shopping cart, in that class, I now expect that render hook ID, or however you want to call it, as a value here on that constructor method. And then I simply forward that, so that value I'm getting here, to the super, to the parent constructor, so that this constructor has access. And now as a side note, render here in my shopping cart also no longer needs to return anything, because I'm not interested in the cart element anymore. I don't need that anywhere in the place where I call render. So now with that, if we save that and we reload, this looks a bit better, but we get another error: cannot set property inner HTML of undefined. This simply is an error here, however, because I'm returning this root element in create root element. That's wrong. It's just root element. So that's simply an error I have in my code. We're creating root element here and we're storing it in a constant. I should return that constant. We're not storing it in any instance property here because we don't need to. So with that fixed, if we now reload this, now that works and it behaves in the same way as before, but now we're taking advantage of this base class. Of course, we're not there yet. I now also want to adjust the other classes so that they extend from component as well. So now that the shopping cart extends component and therefore reuses that logic, we can do the same on the other classes as well. For example, on product item. There, we also start by adding extends and then component. And now here in render, again, instead of creating the element like this, we can get access to the product element by calling this create root element, pass in the tag we want to create, which here for a single item is a list item element, and then any class we want to add, which in this case is product-item. I don't need any attributes here, just as we didn't need any on the card, and therefore I'll not add that third argument here. That line is no longer required because the class will be added here instead of create root element. I definitely want to set inner HTML. That is the logic which has to remain in this render method here. And then here, I want to get access to the button, add the event listener, but no longer return product element. Instead, the created element will be hooked into the DOM by my logic here in create root element here, and we just have to make sure that we call its constructor, so the constructor of component, and forward the ID of the element in our DOM where we do want to add the item. Now, of course, that now is not this div's ID here. Because we're working on a single product item, this should be part of our product list. And previously, it's here in the product list where I called render, and then I appended the returned product element. Now, since render doesn't return it anymore, and of course we still could return it, but I always want to use the same approach, I'll not do it like this anymore, remove that instead. And instead here, when we create a product item, besides passing in product, I also want to pass in an ID of the element where this item should be added to. And that ID is in the end an ID, which should be assigned to that product list. So for now, we'll also change this to use the base class, but for now, I'll go to product list and add an ID, prod list or anything like that, totally up to you. And then use this ID here, prod list, which I pass as a second argument to the product item constructor. Now in the product item constructor, we have to work with that second argument. So the render hook ID is the second parameter we should accept there. So that here we can also call super. And it's a good convention to do this first so that you make sure that your base class is fully initialized before you start working in your subclass. And here to super, I forward the render hook ID so that the base class has everything it needs to make create root element work. Therefore, now if we save that and we again reload here, we'll get an error. Now this one can be tricky to spot, but it's important to understand where it's stemming from. Do you have an idea what could be causing this? Well, we're having problems appending our item in line 37, which is that line here in create root element. So we probably have problems finding an element with that ID. Now the problem is that, of course, in prod list, I assign this ID here to prod list, and then I do pass that same ID to product item. But what happens thereafter? We create a product item object, we forward our ID to it, and then I call render on product item. Now when I call render here, what's the implication of that? The implication is that in the product item class here, or in the object created based on the class, this method executes. There I call create root element, and create root element will create me a list item and try to add it to the DOM. Now that's the part that will fail, because if we have a closer look at product list, we see that yes, we set the ID on product list, but product list itself hasn't been added to the DOM yet. I return product list here in render after I went through the loop, so after I tried to create my product items and add them to the DOM. So until this point, nothing has been added to the DOM, and that's the problem. Now to make that work, let's already adjust this function here in the product list class to also use the base class. So here product list should also extend component, and with that extended, here where I create the product list, I want to use this create root element and create an unordered list here, give it a class name of product list, and now I'll utilize that third argument, an array of attributes, where I want to create a new element attribute using that class we added earlier. And there we can pass in two arguments. The first one is the name of the attribute. That will be ID, so that we in the end add that ID here inside of create root element. And the value for that attribute will be prod list, for example. So what I use as ID here. Now this will create that element there. Now we can get rid of that line and also of that line where I assign my class name here. We also no longer need to return product list here. Instead now, well, we can get rid of that, but instead now we have to make sure that in the constructor of product list, we call the parent constructor of component, and we tell that constructor where to render the product list. And that would be the app ID or the element with the app ID, but to be a bit more flexible, let's just again accept the argument here and forward that to super, so that in the place where we create product list, we can decide where to render the list instead of doing it inside of product list, which can make your code harder to reason about. So now in the place where I use product list, which is here where I create the shop, I create my new product list like this. And I want to call render there. I'm not interested in the return value though, because there will be no return value. I don't want to append anything anywhere. I don't need to get access to my element by ID here anymore. Instead, to product list, I also forward app, this ID. And now product list will be rendered, and it will therefore then only try to add product items after it has been rendered itself. And with that, if we now reload, this is gone. This works again. And if I now add items to the shopping cart, this also works. And now we're embracing this concept of inheritance and of having a base class to share some common logic. Now we adjusted all classes to use this concept of inheritance. Now we can also improve that code a little bit, and I will definitely say there are tons of different ways of implementing this. So if you wanna try this on your own and also experiment with that and maybe find another or a better solution, a shorter solution, definitely try that. One thing I wanna do here is these render calls here, right, are kind of redundant. We create a product list and then I manually call render. Well, that should be done as part of the creation process, I think, because I'm always doing it thereafter manually. So I'll say product list render gets removed here for the cart. Hence here, I'm not even interested in storing the product list anywhere. Same for the shop. Can simply remove that. I need to store the shop in a constant though, because I need it here, but I don't want to call render. And if we go to the product list class itself, where I render all product items, I also don't want to call product item render, and therefore we don't need to store the product item anywhere. Instead, now what we can do is we can of course call render here in the constructor, or this render to be precise, of course, as my IDE corrected it, because we're referring to this method on this object. But even that would be redundant. We would add this logic to every constructor of every subclass. So since we are calling the parent constructor anyway, since we're sharing this parent, let's just do it in the parent. So in component here, when we construct this, I will call this render. The only thing I will now also do there is I will add a render method here. And this is an empty method. So it doesn't do anything useful here. I'm adding it so that if someone looks at this class, this person doesn't wonder why we're calling render here. So that we at least see that such a method exists. Now we can still do something which is called overriding it, because in all the parent classes, I basically implement a special version of render thereafter. So when we do this in a subclass, when we override a method that's defined in the parent class, this will fully replace it. So if thereafter in the parent class we call this render here, it will not refer to this render method there, but instead it will do this in the subclass. And this can be counterintuitive, but there's one simple rule, and it's a rule you already learned actually. Always remember that this refers to what called the method. And for the constructor, that basically is always the object you are creating. It can be a bit strange because in the end you're creating an object by calling new, right here, new product item. But in the end, what the new keyword does is it makes sure that a new object is created and that this inside of the constructor is set to that object. So that's a little bit of magic the new keyword does for you. That's something you can memorize. Inside of a constructor, this will refer to the object that is being created. That's what new does for you, so to say. And therefore, this always refers to the object which is being created, and the object which is being created is always product list, or product item, or shopping cart. It's not the base class. We're calling the constructor of that, but we're doing that in the process of creating a shopping cart or a product list. And only one object is being created, and that is the subclass, or an object based on the subclass. So when we call the constructor of shopping cart, a shopping cart is getting created, an object based on shopping cart. The parent constructor of component is also getting called, but this in this parent constructor will refer to exactly the same as this in the child constructor, in the subclass constructor. It will refer to that object that is being created. And therefore, since that object which is being created has its own implementation of the render method, this render in the parent class will refer to the render method in the to be created object, which is based on the subclass. So now with that, we're almost there. The only thing that's missing now is in the shop, because if you now reload, you'll see an empty screen. And that is because when we create our shop here, the shop class doesn't have a constructor where we would call the parent constructor due to the way shop works. So in the end here in shop, I want to add a constructor. And in that constructor, I want to call super. And we don't need to pass an argument to super actually, because that render hook ID is not really required for the shop, the way render works here. We're not calling this create root element here. So we don't really need a render place for shop. though we could also certainly restructure this code to make it work as such. But we definitely need to call super to make sure that the render method is getting triggered. Now, of course, that also means that we need to extend component here, however. Otherwise, there is no base class which we could trigger with super, or where we could trigger the constructor with super. So now that shop also extends component and calls super, we can reload here and we'll actually get a different error, but at least we can already see the cart is getting rendered. Now, just before we fix that error, an alternative here, of course, would have been to also just call this render like this, because we need nothing else from the base class. So you might argue that extending it might not make that much sense. So you can go either way. You can definitely also just call this render here and not extend component here, because we're not interested in any other feature from the base class. So extending it might be a bit unnecessary. Whatever approach you chose, let's now make sure we understand and fix this error. This error is related to a little specialty regarding fields. In the end, it's just a case that these fields are created as properties automatically when the constructor gets called, but only after the parent constructor, which you call with super, has been executed. And by the way, you would also not be able to create your own properties here in the constructor with this something equals something before super has been executed. So all your fields are basically translated to this field name equals field value syntax here in the constructor, but they're magically added after the super call, so to say, which is why inside of the parent constructor or inside of methods triggered by the parent constructor, you can't access any of these fields. But as I just explained, you also wouldn't be able to access any of the other properties of this subclass here, because you can only add properties, you can only use the this keyword in your subclass constructor after the parent class constructor finished execution, and that includes any methods that might have been invoked by that parent class constructor. So that's the problem we're facing here with this render method being called by the parent class constructor. In the constructor, we already go ahead and we execute render, and we rely on data which hasn't been created yet. Now, it's just important to be aware of that. There's no huge issue with that. It's just something we have to fix here. And here, we can fix that by taking that array, and let's say we initialize products to be an empty array. We could also remove it, and instead set this products equal to that array here then, which means we create this instance property during the constructor. Now, with that, if we save that, it would still fail, because the order is wrong. I'm calling super before I do that, and inside of super, we call render. So here is a case where we should move super after we initialized our local data, which we know the parent component will in the end depend on, because it will call render for us, which then needs that data. So after we switch that order, you see that is gone. Now the problem just is that we're not allowed to call super there. Indeed, we have to call it first, or at least before we do anything with this in our subclass. So that's not allowed. So how can we solve that issue then? Well, this is a quite common use case. You might want to do something with some data which might just not be there yet when you get started. And indeed, the products data would probably not be hard-coded into our code here, but we might be fetching it from a database. So indeed, it might really not be loaded when we try to render everything here. So to simulate that, I'll cut that code and add a new method here, fetch products. And here we could be reaching out to a server. We'll learn how that works in a separate module later when we learn how to make HTTP requests. For now, I'll just set my products there. So I simulate that in this method, I then have access to these products before I didn't. So here I want to call this fetch products inside of the constructor. Now, of course, render will also be called, but here we simply know, well, our render method depends on something where we don't know yet if it's there. So we could add another method here, render products, and move that code where we go through all products into render products. And here in the main render method, we can check if this product, if it is set, and if this product's length is greater than 0, so if we have something to render, then we call this render product. And in our example here, this will not be the case when render is called for the first time, and that's fine. We'll just create that root element and we're done. But I also want to call render products here in fetch products. So I'll also call it here once I got my products. And now with that, we have a setup for a solution which solves a problem you'll encounter quite often, that data arrives after you want to render some initial content. And here we do render that initial content. We do render that list. It's just an empty list initially, but then we add the products as soon as we have them. So now if we save that and we reload, we'll find a similar problem, now stemming from line 97. And this is from inside the product item. There we also call render in the end as part of the constructor, and we only store our product thereafter. And we need that product to render it, right? Now we can employ a similar solution there, or to show you an alternative, go to the base class, and since we have problems with it rendering too early, maybe accept a second argument, render or should render, and set this to true, so use a default argument. Then here we check if should render is true, and if it is, we call render, but now we can override this when we call the parent class constructor. And that's an alternative strategy. So here where we know I want to call render myself, like in the product item, we could pass in false as a default value for, or as a new value for that default argument, so for should render, so that the parent component will not render, and we instead call render manually after we know that the product was set. Of course, this is an approach we could have used down there as well, but here I also wanted to show how you could deal with data that actually is loaded at a later point of time. So where we don't just talk about different sequence steps, but where we might have a bigger delay if we are reaching out to a real server. Here it's just this sequence which is wrong, and with this approach we could fix that and therefore get rid of that. And now we would render everything and we get the same behavior as before. So that was quite a lot of work with the base class and with the subclasses and some different use cases you could encounter and how you can work around them. Overall, it just takes some practice and of course experience to get a feeling for how you split your code and when you use which approach. The great thing about programming is that you can be flexible and that there are different solutions, different approaches you can take, as I hopefully showed you thus far. Now with that, let's go back to our app and let's make sure we can also click that Order Now button. Because whilst implementing this, I can also show you one other nice feature or nice approach you should be aware of when working with classes. In the shopping cart, we also got a button there, right? We got a button which we render here. Of course, I also want to make this clickable, though it won't do much here. And to make it clickable, I'll get access to this button here, Order button, with Cart L query selector, for example, selecting the first and only button we find there. And then, as you're used to, you can add an event listener here. And that event listener can be added to a click event or react upon a click event and should then execute a method. Now here I want to add a method which should be triggered when we click that button, order products, for example. And I won't add much logic here, just some output ordering, and also I want to output this dot items, so my cart items here. So this dot items is what I want to output here. Now it's this order products method which should now be connected to the click listener, and therefore here we refer to this, so to the object we're working on, order products without parentheses, so that the click event executes that for us. Now, as you know, this in there, if I click order, will be undefined here or will not be our object. Undefined here is, of course, actually stemming from the items I'm trying to access. This is not a property that exists on this because this will actually refer to the button. As you can see, if we remove dot items, right, this is the button. This is something we talked about before. Now, I also showed you a solution, of course. One solution, and I'll just quickly re-add that, is to use bind here. Another solution is to here use an anonymous arrow function. If you do this, and that's all it takes, this here is then the function body, then this here, since arrow functions don't know this, will not be bound to what the event listener wants to bind it, because the arrow function ignores this, as you learned, but instead it will keep its context, so to say. It will refer to the exact same thing it would refer to in that code in general. So by wrapping it in an arrow function like this, we ensure that this works. The only thing we now have to do is we have to execute it here. Because this is now the function body of that arrow function, we could add curly braces around it, and therefore this will not execute right away. Instead, we pass a reference to that anonymous function which is created here on the fly to the event listener, and therefore this anonymous function will be executed by the event listener eventually, and the body of the function therefore then only runs when that anonymous function executes, which is why here in the body we have to execute this, so that this does execute when this outer anonymous function executes. And with that, if you reload and you add something to the cart and you click order now this works, and indeed we get access to our items. This is one possible approach. An alternative to that, and let's comment this out, is that you don't use that wrapping arrow function and therefore you get rid of the parentheses there. Instead we use the old approach. But now you set up order products differently. That's also something you can do. You can add it using this field syntax here, because you could add a field named order products, which then simply holds a function that wouldn't change much though. But how about an arrow function? Now we're not using the method shorthand. Instead, I'm creating a field which holds an arrow function. And since arrow functions don't care about what you bound this to, instead they always give you this in the context it would have otherwise as well, this, since it's inside of that class here in the end, will refer to the object created by the class. So now with that, we also ensure that this inside of this function will always refer to the object created by the class and not to what it would normally refer to. And in this case, that would be the button, of course. The only thing we have to be careful about here, though, is that normally this would work, but since render gets called in a constructor when we call super, it will actually be called before a property is created based on that field, right? That's what I explained earlier. The fields are translated to properties after the constructor ran. So to utilize this workaround and this concrete example here, and it's really only because of how super works and how it calls render, we would have to pass false in here so that super does not call render, and then set up this not as a field, but actually as a property with this order products equal, which kind of replaces the field, just so it just executes such that we can thereafter call render manually. So again, this is just a workaround that's required for this exact use case. This idea of storing an arrow function in a property, or normally under different circumstances also in a field, would always work. So now if I reload this, and I add something here, you see that works as before, now using this trick. Now actually, technically, there is a difference between storing a function in a property and adding a method like this, but that's a bit more advanced and something we'll come back to in the next module, where we have a closer look behind the scenes of all of that. So that's almost it for classes for now. Obviously, we'll see classes in many places throughout the course, so there are plenty of other opportunities to practice with them. There's one additional, very new feature, which I don't want to hide from you though. It's extremely new. Browser support is pretty slim right now, but will get better. And since this is a future-oriented course, you'll learn it right now already, so that you can use it in the future, and in Chrome, thankfully, already today. And that would be private fields, properties, and methods. So that private term might not tell you much. Until now, though, I can tell you we only worked with public methods and public properties and fields. But we can actually also work with private properties and fields and methods. Now, the idea behind public properties and methods is that we can access them from outside of the class and object. That's what we did in some cases already. You typically want to make everything public which needs to be accessed from outside, so the things you work with in your other code. An example would be if you have a product and there you have a buy method, which we don't have in our example, but if you have another app, and that should probably be triggered from outside the product object because the place where you work with your product object is probably the place where a user can buy it. You also, on the other hand, have some logic, some methods, or some properties which you need inside of an object, but not outside of it. So the things which you need to make your object work and which you don't really need to trigger or work with from outside. Some hard-coded fallback values or some class-specific logic. Now that's very abstract. Here are some concrete examples in our code. For example, products here in the product list. It's only used inside of the product list class or in the object created based on the class and not from outside of it. The place where I create my product list, here, I don't even store it in a constant or in a variable because I'm not interested in it. So I don't do const list and then set list products to something. And actually, I also don't want to allow it. Because if this would be possible, and it is possible right now, then if another developer works on our project, he might think that setting products like this should be reflected here on our page. But it turns out that setting it like this will only change the products stored in the object, but will have no impact on the rendered HTML. Because in the product list, we have no setter on products that would trigger a UI update as we do it on the shopping cart. Instead, if you would set products from outside the class, nothing would happen. Fetch products is the only method inside of the class which actually changes something there, and which then also updates the UI by calling render products. So I want to make sure that we can't even set the products variable or property to be precise from outside, because it could lead to cases where you think you changed something but it's not reflected on the UI. That's a perfect use case for a private property. Products should only be available from inside product list. And we can achieve this in JavaScript by adding a hash symbol in front of that. Now, this is such a new feature that my IDE doesn't even support it. It will work though, despite my IDE complaining though, because normally indeed that would be an invalid character. You can't add anything but $signs and underscores to your variable or property names. Well, the hash symbol is a new exception with this specific meaning inside of a class or inside of an object, where it then turns this or sets this to a private property. You then also have to use the hash symbol when you access it. So here, for example, this hash products is set equal to that. Or then also here in render products, we refer to this hash products. And also down there, this hash products and this hash products length. And again, you can ignore the errors for now. And with that, we'll now have a situation where if I would store the list here, and I would try to do console log list hash products like this, and I save that and I reload, I get an error that a private field must be declared in an enclosing class. So essentially, I can't use it from outside. So this fails now. If we remove that code, however, you see, it now generally works, but I get a different error, and that error is related to our base class calling render in the end. That base class, of course, does not have hash products. Instead, only our subclass here has it, and private properties are only available in that class where you defined them, not in some base class or in some subclass. And therefore here, when I call the super constructor, I'll also set rendering to false and manually render. And I'll just call this render here. Important, do that before you fetch the products, because there we'll then try to render the products. So we need to render the list first. And yes, therefore, of course, refactoring that and making sure that render is part of the base class doesn't make much sense here, because I override it in most cases anyways. But it was a good practice, and when we introduced it, it made sense. Now, however, it of course doesn't make that much sense. I'll leave it there though for reference and use this approach where I tell the base class that it shouldn't call render. Instead, I call render myself, and therefore I do that from inside the class where that is defined, so where hash products is defined. And with that, if we reload, this again works. Now again, this shows you how you can add private properties, very new feature, will of course be supported by IDEs in the future as well, and can also, even though it doesn't look like it here with all these errors, but can also lead to clearer and cleaner code, which makes your intentions clearer, where you can avoid that some fellow developer, or maybe you in the future, if you come back after a couple of months, accidentally change code or change parts of objects or of classes from outside of them, as I showed you before, when you should only work with them from inside the class, when you have a property that really only can be used from inside that class, and therefore from inside the object that's built based on the class. Now you will also be able to have private methods in the future. For example, fetch products is a method we only use from inside there. So we can also add a hash symbol in front of that and call this hash fetch products, but that's not even supported in Chrome yet, as you can tell. And therefore here I can't show this to you. In the future, this will be available as well. So it's also something following the same logic as with private properties. Methods which should only be called from inside a class, from inside an object, can be marked as private by adding this hash symbol in front of their name. So let's practice classes and object-oriented programming and all the things we learned in this module. Here's an assignment. In task number 1 of that assignment, I want you to create a course class which has 3 properties: title, length, and price, which are all set up in the constructor and initialized with parameters of that instructor. And then I want you to instantiate that class twice. So create 2 objects based on the class, 2 dummy courses, which you of course can initialize with any values of your choice, and output the objects to the console. In task number 2, I want you to add 2 methods to the course class. The first method should calculate a length price value, so divide the length by the price and basically return this number. So how much length do you get for the amount paid, or how much length do you get per dollar, you could say. And the second method should output a nice course summary, some text where you have the title, the length, and the price. Call both methods thereafter and output the result to the console. Now in task number 3, you should create 2 new, more specialized classes which are actually based on the course class: the practical course class and the theoretical course class. So both basically extend the course class, but practical course should also have a num of exercises property, which is initialized with the help of the constructor. Theoretical course should have a publish method, so not num of exercises as a property, but a publish method, which simply prints something, anything of your choice, to the console. Again, instantiate objects based on these specialized classes, and then use and access that new property and that new method. In task number 4, I want you to add getters and setters to ensure that the price property, which we have in the base class, can only be set to a positive value, and that it is returned that when you access it with the help of a $sign. And in task number 5, we can then take it to the next level with the help of private fields, where we can make sure that the getter and setter approach really works and can't be bypassed, which is possible with the implementation in task number 4, but not as soon as you add real private properties. This is your assignment. Have fun with it. And of course, as always, compare your solution to mine, both my attached solution code, which you'll find in the solution part of the assignment, as well as my solution video. So let's dive right in, and let's start with the task number 1. Create a course class which has a title, length, and price property. So for this here in assignment.js, I used the class keyword and then the name of the class, in our case course. And now to add properties, we simply add a constructor here. And then in the constructor, we can accept parameters, but we don't have to. But we absolutely can, and in this case should, add properties in the constructor body by using the this keyword, then a dot, and then the name of the property. So in this case, title, price, and length. Now like this would be invalid code. We also need to initialize them to some values. And here I want to use values which we get as parameters in the constructor. So a course title, a course price, and a course length. We could use the same names as we use down there for properties, but to avoid confusion, I use different names. So then here we have the course title as a value, here we have the course price, and here we have the course length. Now let's create some objects based on that. So here we have the JS course. With new course, we can initialize it or instantiate it. And now to that course constructor, which we're calling here, we have to pass values for these parameters. So here it is JavaScript, the complete guide. The price, let's say, is $50, and the length is, let's say, 44 hours. And then the other course I have here is, let's say, the React course. React.js, the complete guide, same price, but let's say this has 36 hours, something like that. Of course, you can use any values you want. Thereafter, I will console log JS course to the console and console log React course to the console, just like that. If we now save this and we reload, we see this output here for the first course and this output here for the second course. So that is this task solved. Now task number 2. Now we should add methods to the course class, which we can call. One to calculate the length price value and one that outputs a nice course summary. So to add a method, we go into the class outside of the constructor, and here we can simply add a method, calculate value. You can name it however you want, where I want to return this price divided by this length. This is the calculation I want to perform here. Excuse me, this length divided by this price. And then maybe a print summary method where we just console log. Alternatively, you can of course also return a string. Here I will output it right away. Console log, a nice summary where we have title plus title. Actually, let's use a template expression here to make that easier. So title, this dot title, length, this dot length, and price, this dot price. Like that here. And now we can use these methods. So here we'll console log JS course, calculate value, and the same for React. And then also call JS course print summary and React course print summary. So I'm using all these new methods here now. With that, if we save that and we reload, these are the values we get for the course. Of course, the higher the better, because that means that's our value per dollar in hours, you could say. And then here we have the nice summary. So that's task number 2 solved. Let's move on to task number 3, therefore. Here we want to have our 2 new more specialized classes, practical course and theoretical course, which are based on the course class but add new things to it. In the case of practical class, we add a num of exercises property. In the case of theoretical course, we add a publish method. So here I will add a new class, practical course. And now to extend that our base class, I use extends here, a keyword built into JavaScript, and point at course. You can only extend one class, and here I'm extending the course class, which means we inherit all the properties and methods of that class, but we can now also override them or add our own. And here I will add a constructor. Now important, if you add a constructor in a class that inherits another constructor, you want to call super in here to execute the parent class constructor. And therefore here in practical course, I also want to get the title, the length, and the price, but I also want to get my exercises count. And I forward title, length, and price to the constructor of the base class, because there I expect these values, though price should be the second one actually. So let's fix that like this. And now I can also add my own property, num of exercises, which is simply exercises count. And now if I create a new course here, let's say the Angular course with new practical course, we can pass in a name, Angular the complete guide, a length, let's say here we go for 36 hours, a price, let's say that's our good old 50, and then we have 10 exercises, just an example. Now if we console log Angular course, we should see all of that, but for example, we would also be able to call print summary, because this method still is available, since Angular course is an instance of practical course, which in turn is based on course, which in turn has a print summary method. It's defined up there. So now with that, if we save that and reload, down there I get my Angular course output like this. And there we also see the number of exercises, and we see the nice summary also works. Now we're not done, we also need another specialized class, the theoretical course class, which should also be based on course. So I'll add another class here, theoretical course, which also extends course. And in there I want to have the same properties. Therefore I don't need to add a constructor here. If we don't add one, we automatically get the one of the parent constructor. But I want to add a publish method here. And that publish method should do something. Here I just log publishing to the console. Now if we create yet another course down there, let's say the Flutter course, by calling new theoretical course, we can pass in a title. We actually have to. Flutter, build iOS and Android apps. A course price, good old 50, course length, let's say 48, and then nothing else, because that's all we need. But now here we can call print summary, but also, for example, publish, because we added a publish method in the class that extends the base class. And therefore now if we save that, and we now reload here, at the bottom we see our Flutter course output there, but then we also see publishing below that. So that's task number 3 solved. Let's move on to task number 4. And here we will revisit the price property by adding a getter and a setter. So let's go back to our course class here. Price is initialized like this. Now actually here I will name this underscore price, and everywhere where I use it I will also change this to underscore price. Not down there, but here in this calculation. Down here I will not change it, because down there I actually now want to use that getter, which I'm about to add. Now you can add it anywhere, above or below the constructor, doesn't matter. I like to have my fields and getters and setters above the constructor, so I will add it here, but technically it doesn't make a difference. Now you add a getter by adding the get keyword, and then any name of your choice. And here we'll use price. That name is available now because I renamed this to underscore price. And this price here will therefore refer to this getter, because that was what is named price. This now needs parentheses and needs to be defined like a function or like a method, and needs to return something. And here I want to return $sign plus this underscore price, so that it adds that $sign. Now I also want to define a setter, and here I get the value as an argument which the user tries to set. So this will be called automatically whenever you try to assign a value to price. And here I will check if that is negative. So if value is smaller than 0, I will actually throw an error, let's say. Invalid value is something we could throw here as an error. Otherwise, I'll set this underscore price equal to value. So now we only set the price, which is stored internally, to the value the user tries to set if that value is greater than 0, because otherwise we throw that error. Now, of course, you could set a negative price here in the constructor. We would need an extra check here to do this properly, or actually reach out to our setter, so that now in the constructor we also take advantage of our setter. Well, and with that, let's give this a try. Here, when I create the Flutter course, let's try assigning -50 here as a price. If we save that and reload, you see I get this invalid value error here. Now let's use a valid value, and this should be gone. If I use 50 again, a positive number, this works. Now if we try to assign a negative price after it was added, I can access price here and set this to -100. And again, you will see if I try that, accessing it with a dot notation, we also get an error. Of course, if I use a valid value, so greater than 0, like 1 for example, or equal 0 would also be accepted, this would work. If you want to exclude 0, of course, you just would have to tweak that logic here to check if value is smaller or equal than 0. Then you would also not allow 0. Here I am allowing it to allow free courses. So this is this check. But the downside is that theoretically here, we can still access underscore price like this, because this is just named underscore price. It doesn't make it hidden or anything like that. So if someone else works with our code, that someone else would be able to set the wrong property and circumvent our check. Now that's of course not what I want. So let's solve that fifth task here. For that, we need to turn price into a private property. And we do that by adding a hash symbol in front of it. You can replace the underscore or you can keep it, up to you. But this creates a new property in this class, which is named hash price in the end. But the hash is not just part of the name, it also is a signal to JavaScript, which tells JavaScript that this property is private. It can only be accessed from inside the class. So let's also use it here, and of course also in the calculation. If we save that now and reload, you see I get an error though. Private fields must be declared in an enclosing class. Indeed, to use private fields or private properties, you need to define such a field first. You learn fields are in the end just definitions for properties and converted to properties. So what we need to do here is we need to add hash price up there just like this in the class. You could initialize it with a value if you wanted to, but you don't have to. Defining it like this is important though, so that JavaScript knows that this exists and should be private. With that, if we now reload, this error is gone. And now the consequence is that when we assign a value here to .price, so not to .hash price, but just .price, we use the setter, which then in turn will set it to hash price. So now we set this to 5,000. But if we try to directly access hash price from outside, so if I set Flutter course here, hash price to 100, we'll actually get an error because this is not allowed. I get an error that I must do this from inside a class because it is private. So now we protect our code against incorrect usage, and we enforce that everyone who wants to set a price has to use our getter and setter. The value which is getting used internally, for example in this calculation, is not accessible from outside the class. And that's exactly the idea behind private properties and fields. That's it for this tiny project here. Now, definitely you can refactor this, so you can change the code. You can definitely come up with some more elegant solutions. I structured it like this to show all these class features you have available and when you might want to use them. Showed you a couple of different approaches and ways of thinking about that. And hopefully could show you why classes allow us to split our code into logical units, which we then can use to compose our app together, because that really is the idea behind object-oriented programming and behind classes and behind working with objects everywhere, that you have your logic and your data grouped together, and then you just use these bundles of data and logic to put together your application. Now, there are a couple of other things related to classes and to objects which are also useful to know. And for that, let's go here to the console and let's create a class here, which we can do. Let's say a person class here with class person. Place the cursor between the curly braces, hold shift and press enter to write across multiple lines to make it more readable. And there, for example, let's add a field of name with a value of max. And if we now instantiate that class by calling new person like that, P, of course, is an object of type person with a name of max. And it's this type person which is interesting. I haven't talked about this before because you need to understand classes to understand the idea of types here. It's not an official type. If we do type of P, we'll see this is type object. This is not of type person. But still, somehow JavaScript keeps in mind that this was created based on that person class. It's not of that type, but somewhere this has to be stored. Otherwise, the developer tools couldn't show this to us. And indeed, that is stored somewhere. There is a special operator, instance of, and you can use it to check if an object is created based on a certain class or a certain blueprint. You use it by using your concrete object, in this case p, which is this constant that holds the object, then instance of, and then the type or the class you want to check. For example, person, like that, without parentheses, just like that. And this will return true if p was created based on person, or if the value stored in p was created based on person, and it will return false otherwise. And actually in JavaScript, there are a bunch of built-in classes, if you want to call them like this. Technically, it's something else, but that's something I'll dive into the next module. For now, let's call it class. For example, if we select a button, if I store it in a constant button and I get it with query selector button, which should yield me that first button, that order now button here. If I print that, I get it like this, but if I console dir button like this, I get the object. Now here I got a different representation, but the interesting thing is there is a type, a class built into JavaScript, and you find something like that on MDN, that's how I know that, which is called HTML button element. That's basically a class, you could say, built into JavaScript or built into the browser, exposed to JavaScript. And the button, btn, is an instance of that. If we check that, we get true here because it's of type HTML button element. Side note, HTML button element extends from HTML element. So that's a base class, so to say. And therefore button also is an instance of HTML element. It's, for example, not an instance of person, of course. Now, I'll dive deeper into these HTML elements, where to read more about them, where to find all of that in the DOM deep dive module you'll find a little bit later in the course, not that far away. But it's nice to know right now that you have these built-in classes and that the instance of operator here helps you find out if an object you have is based on that type, based on that class, or not. Speaking of built-in types, there also is a global object type or class. And you can use that to create objects. Indeed, you can do new object like this. And when you do that, object here, object, in the end is just an empty object. Indeed, new object like this is pretty much the same as doing this here, creating an object with an empty object literal. Now, this here, the object literal, is actually preferred because this is a little bit slower, both to type and regarding the performance, and it doesn't yield an advantage here. It's just a built-in base class, which will become a little bit more important in the next module. Typically, you don't use it like that, though. You might also remember that we did new array to create a new array, or that we could do that at least, but there also the literal notation is preferred. And you got a couple of other built-in classes, and we'll see them from time to time throughout the course, no worries. And with that, let's conclude this module with something which is not directly related to classes, but related to objects and to object properties, and where a little bit of a deeper knowledge about objects, which we have by now, doesn't hurt. And that are object descriptors. Let's create a new object here, and that can be a normal object, or we always worked with normal objects, but I mean it can be an object created with the object literal notation. Don't forget that there use a colon to separate key name and key value. And then I have my, name here. I also have a method in there using the shorthand where I say console log this name. And now we have person here. We can call greet on person, all is good. Now actually every property you add and every method you add as well, it's basically a property which holds a function, has a so-called descriptor. So let me clear that. It's not lost, it's just clearing that output here. We can have a look at the descriptor with object get own property descriptor, then pass in the object person, and then the property key. Alternatively, call get own property descriptors and just pass in the person or the object, so in this case the person, and what you'll get back is a new object with this so-called property descriptors. Now that's some metadata stored behind the scenes by JavaScript. It influences how the properties can be used. So that's some configuration JavaScript sets up for you and stores for you, which you can change though. So let's have a look at the name property. Here it is. We see it has a value of max, that's what we assigned, but we see 3 other configuration items as well. Configurable, enumerable, and writable. Now this simply means that this property, the name property on the person object, holds a value of max, that we can assign a new value so that it's writable, that it's configurable, which means we can, for example, delete it, and it's enumerable, which means it appears in a for-in loop. And for greet, we got the same configuration. We see the value is a function. Other than that, it's the same. Now, thus far, I haven't talked about that because often these defaults are okay. But sometimes in advanced programs, you might want to lock down a property. You want to make sure that it can't be written to, for example. Well, to do that, you can use object and then define property, pass in the object, person, then your property, name, for example. So the property you want to change or you want to add, you can also add a new property with that. Here I want to change the property with the name, and you have to pass that in as a string, of course, because like that, it would be looking for a variable named name and then use the value stored in that value as a property key it's looking for. So use a string here. And then the third argument is an object which describes the descriptors or which sets the configuration for your object. So basically an object which can have these 4 values. Every value which you don't set gets false now. So here I created a new line with Shift Enter. And then, for example, we can set configurable and make sure you don't mistype to true. And in another new line, enumerable to true. And in another new line, value maybe to max to keep that. Or of course to person.name to take the current value in there, which is max. And set writable to false now. If you hit enter, get the same object as before, but what you'll notice is that if I try to access person.name and set this to Maximilian, person still has max in there. It didn't throw an error, but it didn't accept the change. Now this is a way of locking down this property. Now we can still delete it though with person.name. Now person no longer has a name. We could have prevented this. I am pressing the up arrow key here to cycle through my past commands by setting configurable to false, for example. Now I'm re-adding the name property. You see if I output person, name is back. It's undefined because I set it to this value here, which of course didn't exist anymore. But you'll see if I delete person name, it's still there because I set configurable to false. Now enumerable also can be useful to set. Right now if we add a for-in loop and we go through all keys in person and I then just output my key here, you will see it outputs greet and name because these are the 2 properties I have in the end. Greet is a method, but in the end, as I said, that's just a property which holds a function as a value. Now, often when you use for-in, you want to make sure that functions, methods, are not included. You only want to go through your properties that hold values other than functions. And here, for example, using object define property can be useful again. For name, I'll set this back to max, but other than that, keep the configuration and set enumerable to true. And actually, I'm getting an error now, of course, because configurable was set to false. So I kind of broke this object. To fix it, let's simply add name 2 here. That works. And now, more importantly, I want to go to greet, which is that method. And there, I want to keep the value. So the value stays person.greet. So whatever I had stored in there will be kept. But enumerable can be set to false. I'll set configurable to true, but enumerable to false. The result of that is that if I now re-execute this for-in loop, You see name and name2 as output, but greet is no longer part of that because it's not enumerable, which means in for in loops it will be skipped. And that can be useful because you might remember that in the objects module, we had this case where I went through all keys in info and I checked if the key is not title and not underscore title. By the way, I used underscore title back then because we hadn't learned about private properties yet. Anyways, I used this if check here to make sure that I didn't use these properties here for outputting my extra information. Well, now with the new knowledge, we could have just set the object descriptors such that title and underscore title are not enumerable and they wouldn't occur here in that for in loop. So that's where this can be useful. It can be useful to make properties unwritable, not deletable, not configurable in general, or to exclude them from for in loops, which of course is advanced and rarely needed, but in certain cases, like for example here, it can be useful to be able to do that. So this is it for this module. You learned a lot about objects and there, most importantly, about object-oriented programming and classes. Classes are blueprints. Blueprints you use to create objects based on them with the help of the new keyword. The new keyword and then by executing the class like a function, like we're doing it here for example. This creates a new object which you then can use or can ignore, like here if you don't need to do anything with the object. But you can, and that's the important thing about classes, you can add data and logic inside of the class. You can use public and private properties. You can add a constructor to define logic that executes right away when the object is created. You can group any logic you need into that class. And you can also use inherence to share common functionalities like here, create root element. This allows you to split your code into reusable units where your objects and your classes are the units that hold your logic and your data, and you then build your app from these units. Certainly a different way of thinking about your program, also not the only correct way. You can also work with functions and so on, but an approach which often helps you structure your code in a cleaner, easier to understand way. Therefore, classes are super important, as always, and as you saw already in this course. We'll of course keep on using the features you learn about, and of course we'll keep on using classes. You will see them again in other parts of the course. It's a core concept of modern programming and something you'll see in many applications you build with the help of JavaScript. It's not a must use everywhere, but really useful to understand.